This video is going to show you the general trends you can get between elements by knowing their relative positions in the periodic table. First of all, notice that, or remember that the nonmetals are in the upper right hand of the periodic table and the metals are in the hand. This is just a silhouette of the periodic table right here. And the division between the two, if you remember, is right here. It's kind of right along this area. It's a diagonal line that kind of separates the two. All the trends that we're going to look at are run perpendicular to that line, which makes sense because they depend more or less on whether things are more or less metallics. And we can look at the periodic table to get that first trend, which is the trends in the metallic character. So as you go from the upper right down to the lower left, it makes sense that elements become more metallic on that. So that is the trend in the metallic character right here. All right, so then the other trends kind of build off that. We can look and also at the trend in atomic size, and generally speaking, the nonmetals are smaller than the metals, and it's not just dependent on the number of electrons. So the size of the atom, or the atomic size, sometimes it's called atomic radius, is an interaction between the number of electrons. So you would think that the number of electrons would make atoms larger, and it does to some extent, but it also depends on another property called shielding, because as you get more and more electrons in an atom, you also have more protons, and the protons pull on those electrons to make them smaller. So it ends up that the elements do get larger as you go down in the periodic table. So that's the trend for the increasing atomic size. But they also get larger, not from left to right, but from right to left as you go this way in the periodic table. So the general trend in the atomic size is to go from the upper right to the lower left here. That's the general trend. So the larger atoms are in the lower left, and the smallest atoms are up here in the upper right. Is ionization energy. That goes reverse to the atomic size. The smaller the atoms are, the harder it is to ionize the electrons. And so the general trend for the atomic size, for the ionization energy, really goes the reverse of the atomic. It's harder to ionize electrons the smaller the atom is. So the ionization energy then increases going this direction in the periodic table. Larger ionization energies in the upper right. And then the last property that I'd like you guys to know about is actually not in this chapter, but we will be talking about it. That is the property of electronegativity. Okay, electronegativity is the tendency of an element to pull electrons toward itself when it's in a bonding situation. And nonmetals are better at doing that because nonmetals like to hold on to their electrons anyway, and they also like to pull other electrons toward them. So the trend for electronegativity is the same trend as for ionization energy. The more electronegative an element is, the more that it pulls electrons towards itself. So the trend goes this direction, towards the nonmetals. There's one thing you have to know, though, that's an exception to that, and that's the fact that the noble gases, which is the very last column here in the periodic table, the noble gases do not even have electronegativity values. So the element with the highest electronegativity is just to the left here of neon. It's the element fluorine. So fluorine has the highest electronegativity value of all the elements.